Hello everyone, this is Professor Lee again, and today we are going to talk about continuous probability distribution and especially uniform distribution, right? Uniform distribution in this chapter. So, if you check out some of those learning objective, it's first we are going to go for the general understanding of what's called the continuous probability function, and we're going to introduce the uniform distribution function and some of those basic calculations of uniform distribution function, right? Basic calculation. All right, so let's start with the properties of continuous probability distribution. Now, the graph of continuous probability distribution is a curve, right? So you can actually graph the probability distribution function, and it's going to be most likely in the form of some type of curve. And the actual probability is going to be the area under that curve. And that curve is called probability density function. We are going to abbreviate that as a PDF, probability density function. And we are actually using a usual function notation, the f of x, right? F of x, that function, usual function notation for this probability density function. And that f of x is the function that corresponds to the graph. Now, I just went through some of those basic properties of probability distribution function. And, as you can see, this is really very nice and fancy, but, if you don't have a strong math background, this really doesn't mean much, right? Talking about some type of function, whatever, right? Whatever. So let me go one by one later on with the actual example. Now, when they say probability density function, there's some other basic properties. The outcomes are not counted, but measured, and the entire area under the curve and the above x-axis is equal to 1, and the probability is found for the interval of x value rather than individual x value. So these are all the basic properties of what's called continuous probability density functions, right? So it's going to be interval rather than value, and probability that some x value is going to have some particular value between C and D. That means that it's a random variable x is that interval between the value C and D, right? That's how we write it. And, without equal sign, with the equal sign, in probability, they are the same. Now, do you remember that empirical rule, right? That we did a few chapters ago. Let's say we took our exam that the class average was 80. And professor says the standard deviation was 5. That means, now if you remember the empirical rule, that's going to be 80 right in the middle. Then it's going to be 1 standard deviation up, so it's going to be 85. 2 standard deviation up, 90. Then it's going to be 95 here. In the same way, if you go down, that's going to be 75, 70, and 65. Now remember that one. Now, this is a graph, right? And it's in a form, talking about this blue graph right here. This is a graph. And this is form of a curve. Remember that we talked about this is actually form of curve. And this is exactly what they are talking about right there. Now, probability represent the area under the curve. It means something like this. Now, if we have this empirical rule and this graph, now if somebody says, oh, so if this was your class result, what's the probability that if I just pick one student from this group, that that student is going to get the result anywhere between, let's say, 80 to 85. If somebody asks me, oh, what's the chance if I just pick one student from this class? What's the chance that that student's exam result is from 80 to 85? Then I will say 34% because that's the interval there and that's the corresponding probability, right? And that's exactly what they're talking about there. Probability represent the area under the curve. And can you guess the name of this curve? The curve is called probability density function. So now we know name of this curve right here. This is probability density function. That's the name of this curve. Now, it also says we are going to use f of x to represent the curve, and f of x is the function that corresponding to the curve, to the graph. Meaning, this is a nice graph, nice bell-shaped graph. This must have the actual formula, right? The actual formula, whatever that it looks like. So we are going to use this probability density function, and that curve can be represented as the actual function. And that's what they mean by these point right there. And also that they say the outcome measures not counted because this is nice continuous curve. You don't necessarily count these, you measure these. And the entire area under the curve is going to be equal to 1. What does that mean? That means, if you add all these percent, that should add up to 1, right? It's 100%, 1. We talked about that, right? Before. And probability found for the interval value x rather than the individual x. So it's not like what's the chance of that you will get the exact number 85. You don't really ask that question in probability density function like this. Rather, you ask the question like, oh, so what's the probability that you will get between 80 and 85? Something like that. You ask this question using the interval. And that's what they are saying right here. So probability between the certain point C and D is the probability the random variable x is in the interval between these two values. And that is going to be the actual area under the curve. Meaning like this, if somebody said, oh, so what's the probability that if I pick just one student, that student will get anywhere between 80 to 85? What's the probability here? Then how do I find that probability? Well, I calculate that probability by looking at these area under the curve between these 2 points, and it happens to be 0.34, which is 34%. So this is actually going to be 0.34, just like that. And that's exactly what they are talking about right here. It's going to be the actual area under the curve above the x value between C and D point. In this case, between 80 and 85, just like that, right? Just like that. Okay, and what was the last point right here? We are going to treat this without equal sign with the equal sign as the same, meaning like here, this is exactly same thing as probability. The x value is going to be between 80 and 85, but if I put the equal sign right here, this with the equal sign, this without the equal sign like that, these are the same thing when it comes to calculating the probability with the probability density function, right? So that's what they're talking about, all this, very, very technical point. Now, if you can understand these point, then that's good, good for you. It's really nice. If you do not really 100% understand these point, that's still okay. I mean, you can still solve these questions, but that's the basic, theoretical properties of what's called the continuous probability distribution function. All right. Okay, so basically what we really need to remember at the end when it comes to that continuous probability function is this one right here. The actual probability and then area under whatever the curve that you have is going to be the same thing. The probability of that interval and area between that interval is going to be exactly the same thing, right? And the maximum probability is going to be the maximum area that you can have under the curve. It's going to be 1, right? So that's the maximum probability is going to be 1, of course, because in any curve, whether it looks like this or whether it looks like this, the area under the curve, they are all just going to be what? 1. This is going to be 1, and that's going to be 1, right? All right. So that's a general probability density function property. Now let's try to move on to the uniform probability distribution function. Now, before we get into the uniform probability distribution function, so let's talk a little bit about the geometry, right? Let's say you have this nice rectangle. How do you find the area, right? Do you remember that the formula to figure out the area, this blue area of this rectangle? How do you find the actual area? Well, if this side is 2, let's say if this side is 10. And what was the magic formula? Well, the area of the rectangle is going to be what? It's going to be the base times the height, right? Base times the height. So, it's just 10 times 2 or 2 times 10, same deal, right? Height times the base times the height. So whatever that we have here, you just multiply, and that's that. That's 20. Okay, so that wasn't too bad. Now, let's check out this question then. What if the total area is going to be 1? We know that the total area is going to be 1. Ooh, that color matching is too bright. Let's say 1. Oh, that looks like an eye. So let me get rid of it, right? So, the area is just 1. total area. What should be the height of the rectangle when the width is 8? What are they talking about? They're talking about this. The width, the base, is going to be the 8. I want to know what this height is going to be when the total area of this rectangle is going to be 1. So let me give you a little bit of time and think about this. What should be the height? Because I know that height times the width is the area, and they are saying that area is going to be 1. Right? Now, I'm sure some of you already figured it out. Right? So the height, we know that the height times the width has to be 1. I want to figure out this height. How do I solve this actually? Well, h times 8 equal 1. So you divide both sides by 8. Then this cancels out. So your h is going to be 1 over 8. Right? Just like that. So, I mean, it's not that difficult to see, right? Now that we know the answer, if this is actually 1 over 8, you multiply this and this times 8, you know that it's going to be 1, right? Because this cancels out, just becomes 1. So if the height is 1 over 8, then that's it. We have our answer. That's what then the whole area is just going to be 1, and that's what they want, just like that, right? Okay, so let's actually check out the actual uniform distribution. Now, the probability density function, remember that we talked about the PDF, right? The PDF, probability density function that describe the curve looks like this. Now, in this case, it's not going to be a curve, it's going to be a straight line. But it's saying what? Between the interval A and B, between these 2 points. I'm talking about these 2 points on a graph. I mean, this graph is not really proportional, but let's say if this is this 2 interval. Now, what would you say the distance from this point to this point? Let's say if this is 1, let's say this is 9. If this is 9, what would you say the distance between A and B? And how do you find it? Well, it's a 9 minus 1, which is 8. So technically, B minus A is going to be this distance between A and B, right? Now, so if this distance between these 2 points, right? Let's say if this distance between these 2 points is going to be A and B, right? I mean, B minus A. What should be the height of this rectangle? What should be this height of this rectangle so that the total area of this rectangle area is going to be 1. Why is it 1? Well, that's to deal with this probability density function, right? The total area between those 2 intervals, from the lowest point to possibly the highest point, the total area must be 1. So if this is b minus a, the height is actually going to be 1 over b minus a. So, if I draw this rectangle more realistic proportional way, let's say this is A point and this is B point, and you know that this distance between here is B minus A, like that. What should be the height? And how do you find this height? Remember this question right here, the previous question? If that was an 8, height is going to be 1 over whatever that we have here. So that when you multiply, it becomes 1. Exact same idea. If this distance between here is b over a, then we know that height has to be 1 over b minus a, just like that. And that's why they have this dotted line right here. And then this is going to be 1 over b minus a, just like that. And so that is what? 1 over b minus a. That's going to be the actual probability density function for this uniform distribution. Now let me ask you a question. Is uniform distribution always looks like this rectangle box? Answer is yes. Uniform distribution always shapes like this rectangle? Answer is going to be yes. Now, if we are dealing with the uniform distribution, how would I know that we are dealing with a uniform distribution? Well, in our case, the question will tell us this is a uniform distribution that you are dealing with. What are the characteristics of uniform distribution? Well, it looks like a box for one. And if I have this 2 point of this base length, I can figure out the height. Because if it's A and B, the width right here is going to be B minus A. The height is going to be 1 over B minus A, just like that. And also, there are 2 pieces of information that we need to know. One is this one right here. And another one is this one right here. Do we remember this symbol, right? Now, this is one of those symbols that I want you to memorize instead of looking it up. This is what? This is a mu. What's mu? Mu is the mean. So I'm talking about the average value. Average value between A and B. How do you find the average value between A and B? Well, of course, you add it up and divide by 2. That's it. So in uniform distribution, this is how we find the mu. Remember that we were dealing with the binomial. We also had that the formula for mu, which was what? Which was n times p, right? Now, for uniform distribution, we have a plus b, right? That's our formula for mu. Do you remember this formula right here? This formula, right? That's a sigma. That's a standard deviation, right? That's a standard deviation. So how do you find the standard deviation? Well, square root b minus a square divide by 12. Why 12? Well, I mean, for now, for us, we'll just take it as 12. But if you want to prove and really know why this is 12, then you probably need to take 2 more stats course. Then they'll probably, maybe, will deal with why this is going to be the 12, right? But let's just say for now, 12 will give us the best approximation for the standard deviation value for uniform distribution case, right? So remember these 2 formula, right? Or at least know where to find these 2 formula, right? So mu, mean, and sigma, the standard deviation for uniform distribution formula is right here, just like that. Okay, So let's talk about this uniform distribution that illustrated here. Now, given that the actual big box is ranging from 2 to 9, right? 2 to 9. And so from 2 to 9, what would you say the distance between these 2 points? In other words, what would you say the width of this if it's 2 and if it's 9? Well, 9 minus 2, 7. So that's going to be 7 right there. Is it really 7? Yes. 1, 2, 3, 4, 5, 6, 7. Yes. So if this is 7, what would be the height? What would be the height? Now, some of us already remember, right? Height is going to be 1 over whatever the width that we have. So height is going to be 1 over 7. That means if you just backtrack this number right here, that point right here is going to be 1 over 7, just like that. Now, this graph is, you can see that it's totally not proportional, right? It's totally not proportional. If you really want to draw this proportionally correct, this would probably look like this, or even narrower. So this is actually going to be 7, and that height is going to be 1 over 7. It's not even 1, right? It's this, not even, it's just way smaller than this. So in real proportional graph, it's even narrower than that. But you don't need to draw this in proportion. So that's why they do it like that. Now, but the actual question in this graph is actually where? It's actually here. They want this purple area, right? Right? They want this purple area. So how do you actually find it? Look at this rectangle right here between the point 3 and 6. What would you say between 3 and 6, this width right here? 1, 2, 3, or 6 minus 3. So this is 3 and 6. So this is going to be 3 right there. You can do 6 minus 3, right? The bigger number minus small number. So you know that the width is 3. What's the height? Well, height that we know is going to be 1 over 7, right? So if you have a rectangle that height is 1 over 7, the width is 3, the area is going to be the base, the width times the height, or height times the width, 17 times 3. That will only multiply to the top, so area is going to be 3 over 7. But you know that the area is actually the probability, right? The area is actually the probability. So, if you try to actually answer this question, when we have a uniform distribution like that, probability that it's going to be between 3 and 6 is what? It's going to be the actual area. So 3 over 7. And that's this area right here, right? Just like that. And that's how we interpret this uniform distribution. And that's how we interpret this graph, just like that, right? All right. So, I mean, basically that's what they're doing, right? They try to figure out the base, the height times the base. So height, they figure it out as 1 over 7. That means if I put the dotted line, that point right here is going to be 1 over 7, right? Just like that. So the height is going to be 1 over 7. The base of this inside rectangle is going to be 3. So 1 over 7 times 3 is going to be 3 over 7. And that's what we have. And so if you have the uniform distribution, now let me go back here actually, just mention this part right here. Get rid of all that. See that part right here? What does that mean? That X means we are dealing with the distribution, right? And this U means that we are dealing with the uniform distribution. What kind of uniform distribution? The smaller interval, the lower value is A, the bigger value is B. And that's how you write the uniform distribution. So U and the smaller number and the largest number, right? Smallest number and the largest number, these two intervals. That's how you write the uniform distribution. So for distribution that looks like this, distribution that looks like this, that distribution that I can write it as, oh, this is a uniform distribution. How do I know this is uniform distribution? Well, look at the shape. It's a totally box shape, right? This is totally box shape. Uniform distribution. What's the smallest number? Here. What's the largest number? 9. And that's how you write this uniform distribution. So that means in this uniform distribution, I can get any number between 2 and 9. I can get any number between 2 and 9. But if somebody says, oh, okay, then if you just randomly choose any number between 2 and 9, what's the probability that that number is going to be between 3 and 6? Right? Let me repeat that again. I can get any number between 2 and 9, and I have an equal chance of getting any number between 2 and 9. Then what's the probability? Then that number that you are going to choose is going to be actually between 3 and 6. And how do you find that? Well, we just did. It's going to be 3 over 7. Right? We found this diagram. It's going to be inside this rectangle. It's going to be between 3 and 6. The base is going to be 3. The height that we figured out using the original big interval, which is 1 over 7. That's why we were able to figure out this actual area, the actual area between 3 and 6. That's the exact same thing as the actual probability, right? And that's how we found this right there. Okay. All right. So let's talk about this example right here. Right, let's talk about this example. So let me just. All right, so considering this function, f of x is 1 over 20 for x values between 0 and 20. And x is just going to be any real number. The graph of this function, f of x equal 1 over 20, is a horizontal line. However, since it's restricted between 0 and 20, that means you can get any number only between 0 and 20. This is the typical uniform distribution shape. Remember, the x value is going to be between 0 and 20. That means this distance, let's say this is a and b, right? So b minus a, I mean, it's obvious because it starts from 0, so 20 minus 0, which is 20. So this length, the width, is going to be 20. If this width is 20, then you know that the height is going to be 1 over 20, just like that. When they say this fx equal 1 over 20 is a horizontal line, what are they talking about? They are talking about this horizontal line as this line right here. So you're supposed to extend it, this horizontal line. But they are saying that we are going to restrict our portion between 0 and 20 because of this original restriction. We are only going to consider from 0 to 20. Right? That's why we don't need to have all these extra lines. It's just going to be between 0 and 20, these lines. So our uniform distribution looks just like this, right? Between 0 and 20, height is 1 over 20, and it's nice box shape, just like that, right? So if I want to describe this uniform shape, uniform distribution in the actual mathematical language, I'll say X is a uniform distribution between 0 and 20, just like that, right? All right. And, they are basically saying whatever that we just said all here, right? The base is 20, the height is this, area, of course, this total area is just going to be 1, right? Base, which is 20 times the height, which is 1 over 20, it's going to be 1, just like that, of course, right? Okay, now look at this. Suppose you want to find the area between 0 and 2 only. Suppose you want to find the area between 0 to only for the same distribution, uniform distribution. That means, the original big box is our uniform distribution, but you only want to find this area right here. I mean, that's a easy question, I think, right? The width is going to be 2 times the height, 1 over 20. So, this number only multiplied to the top, right? Single number. So 220, 1 over 10, right? Just like that. 1 over 10. So let me get rid of this. All right. And then 1 over 10, if you convert that into a decimal, that's a 0.1. So if somebody said, oh, I want the area between 0 and 2. Another way of saying that is this. Probability. I want the probability between 0 and 2. 0 and 2. And that's going to be 0.1. And that's what we have right there. Okay. What about this though? I mean, why would they say this is equal thing as P is going to be X less than 2? Why is it the same thing? In usual mathematics, these two are not the same thing. But since we are dealing with the uniform distribution between 0 and 20, this is a uniform distribution 0 and 20. So within that uniform distribution, if you say, oh, X is going to be less than 2, less than 2, that means it's going to be between 0 and 20, just like that. So you don't have to say, oh, it's up to, it's starting from 0 and 2, because that's a basic assumption when we are dealing with this uniform distribution. So you don't have to say it twice, right? That's the deal. Okay. So suppose that you want to find the area between for the uniform distribution 0 to 20, that same uniform distribution, area between 4 and 15. 4 and 15. Now, let me give you a little bit of time. Try to draw that box. Try to put those two numbers, 4 and 15, and see if you can find the area. Same thing as that probability. So let me give you a little bit of time. So this is same question as find the probability that x is going to be between 4 and 15. Right? Find that probability. So let me give you a little bit of time. All right? Draw that box, 0 and 20. You know, draw that box inside between 4 and 15. Doesn't have to be super accurate graph. Find the base of those inside box by doing 15 minus 4, I think, right? And then height is the same. It's always 1 over 20. Right, so give a little bit of time. And if you've already figured it out, try to write it in a proper format. All right. So this is the graph, right? This is the graph. We have from 0 to 20, but what we really need is from 4 to 15. So what's the width? 15 minus 4, which is going to be 11, right? This is going to be the base of the rectangle. So the base, the area is going to be base times the height. 11 over 20, which is 0.55. So probability that it's x is going to be between 4 and 15 is going to be 0.55. Just like that, right? Just like that. All right. What about this example? Consider the function f of x is going to be 1 over 8 for the x value between 0 and 8. Draw the graph of f of x and also find the probability that is going to be between 2.5 to 7.5. I mean, you have the answer right here, but you know, the graph is going to be between 0 and 8, right? And then you know that height right here to here is going to be 1 over 8. Now, they say they want the probability between 2.5 to 7.5 right there. So how do you find this width right here? Well, that's a 7.5 minus 2.5, which is what? Which is really 5. So that width right in the bottom is going to be 5. What about this height? Well, height is 1 over 8, right? Like it's given right there. So the area, which is the probability, is going to be 5 times 1 over 8, which is 5 over 8. Type it in the calculator. That's what you get. Just like that, right? Just like that. So, I mean, it's not horribly difficult, right? If you just look at all this box shape and try to figure out the area inside the box shape, another rectangle right there, and basically that's a basic properties and examples of uniform distribution, right? Now let's try this one. Ooh, okay, so we got this. They say we are dealing with the distribution. We know that this is uniform distribution, right? And it's between 0 and 20, right? 0 and 20. And they want the probability between 2 and 18. So let me give you a little bit of time. Why don't you draw that graph? Draw the graph of this uniform distribution first, and then we'll check it, right? Draw that box shape, and then we'll check it, right? All right. Okay, from 0 to 20. So, I mean, they did it without the graph, but let me give you the graph here. So, you know what? Let me draw it again. So it's going to be these two lines. And we won from 0 to 20, right? Okay. We won from 0 to 20. So this is 0, this is 20. So our box is going to be this box right there. Now, what's the height then? Height is going to be, since this is 20, it's going to be 1 over 20, just like this. So that point right there, the top, is going to be 1 over 20, just like this. Now, they want the probability between 2 to 18. 18. So they want this area in the middle. So what's the distance between 2 to 18? Well, 18 minus 2, 16. So this is going to be the base times the height, just like that. So it's going to be 16 over 20, or 8 over 10, or 0.80, just like this. And that's basically, they're trying to put it in like a formula type, right? This C and D is like 2 and 18. So this f of x is the usual f of x of that line, which is 1 over 20. And this is going to be 18 minus 2, which is 16. Right? So they give you the f of x, and they give you this times this 16, which is 0.8. I mean, it's basically exactly what we did, right? All right, so I think we can cut it here, and from that percentile question, we can continue with the other lecture, right? So this would be the wrap for this lecture. Okay.